Welcome to the recording of Azure Innovation Day. This video includes 3 presentations. First is Azure Modernization with Dallas Monson. Second is AI and Cognitive Services with Derek Andre. Third is App Services for Enterprise Apps with Zach Gardner. This event was hosted by Keyhole Software in partnership with Microsoft.
I want to welcome and thank everybody for joining us for Azure App Modernization and Innovation Day, partnering with us at Keyhole Software. My name is Ryan Conway, and I'm one of the business development directors at Keyhole, along with Chris Bristow, Kyle Hay, and Matt Eastlack. As a Microsoft partner, we definitely know that there are so many interesting innovations at Microsoft. We're excited to introduce a few of them today. We especially want to thank Michael Querimit from Microsoft. We were originally supposed to hold this event at the Microsoft Technology Center here in St. Louis and Kansas City, but times changed, and with the change, we were able to invite a lot of our friends from all over, including Nebraska, Indiana, Arkansas, Texas, and New York. With that being said, I know Michael would like to say a few words and like to introduce Michael Querimit with Microsoft.
Welcome, everyone. Thank you for inviting me. My name is Michael Querimit. I'm an Azure specialist in the app dev and DevOps space of the Enterprise Commercial Organization of Microsoft in South Central region of the US. What I want to do today, just really briefly, is talk about the pace of change. And with the accelerating pace of change around us, every business needs to respond and evolve faster than ever before, right? What we find is that businesses increasingly rely on rapid innovation, the ability to sort of roll out new business models, optimize business processes, or respond to regulations, right? And this is more even evident right now with COVID-19, as we see organizations and in corporations pivoting frantically almost to continue to be operational and hopefully even solvent. What we see as we speak to technologists throughout the region or just even nationally is there's a common theme that roughly 72% of IT budgets are forced to just be used to just keeping the lights on. And what that means, sadly, is that about 28% is left for innovation. And so what you're going to hear today is about how we can squeeze out more of that IT budget to do things that are innovative and therefore enable change. So what the message that you're going to experience today is that with Microsoft Azure, those of you that are on the phone, the technologists that are on the phone, you're empowered to achieve more. You'll see that if you look at the cloud app continuum, you'll see there are different paths that you can use to take advantage of the Azure cloud platform. And so for this audience, the topics you're going to hear today are going to be focused around that app modernization section that we have outlined in that dotted box. The point here that I want to make sure that I share is that when it comes to modernization or just the ability to change as an organization, right? The cloud, Microsoft Azure, enables you to do that. And whether you're rehosting, refactoring, re-architecting, rebuilding, or replacing, at Microsoft Azure will meet you where you need to be. So the next thing I want to say is it doesn't matter whatever your tools are, whatever your languages are, whatever your apps are, on the Microsoft Azure platform, every developer is welcome. So with that, I just kind of want to just leave with you this last quote from Satya's book called Hit Refresh. Those of you who haven't read it, it's a great read. But what he says in there is our industry does not respect tradition, and what it respects is innovation. So with that, I challenge all of you guys on the phone, all the technologists on the phone, to be bold, be creative, be transformative, and don't be afraid to be disruptive. So I'll close out here now and give it to the rest of the team. Thank you to Ryan and the Keyhole Software team for quickly evolving on what was originally designed to be an in-person event to a virtual digital experience, right? What we found was interesting was, despite the social distancing that we're all forced to have, we've been observing that with this approach, the team has been able to extend its reach to include folks from a variety of geographical areas. So hi to my friends down in Arkansas and my friends down in Omaha. Hello. Thank you, and enjoy the rest of the day. Back to you, Ryan.
And with that, I'll go ahead and send it over to Dallas Monson with Keyhole Software to get started with Azure DevOps. Dallas?
All right. Thanks, Ryan. As Ryan said, my name is Dallas Monson. I'm an architect, senior architect at Keyhole Software, and have worked with a lot of large and small and medium scale organizations doing modernization and lots of cloud work. Today I'm going to talk about application portfolio modernization, which is a little bit higher level than just single app modernization. We're going to talk about kind of how to marry the strategic thought of modernizing an entire portfolio with some of the tactical bits that Azure can help you leverage and make that an easier process. Now I'm going to share my screen, and I'm probably going to disable my video just so it's not a distraction, because yes, I have been cutting my own hair in here lockdown. So once, like I mentioned, we're going to talk about application modernization and more specifically portfolio modernization. And throughout this, got a lot of information from Microsoft that we're going to be sharing about some of their modernization activities that they've done internally, and also a lot of the modernization challenges that I've encountered working in a lot of the different, with a lot of our different partners. So, your business is basically a software business. Every business essentially is a software business. And the reason why I say that is because at some point in some fashion, you have these external facing applications, internal applications, line of business applications like SAP, CRM, kind of backroom things. All these applications, maybe an external website, maybe some sort of B2B application, regardless of your vertical, whether you're in healthcare or finance or retail. In the past, you were a retail company or a finance company or a hospital or healthcare company. Now these software programs have become so inundated and so ingrained into your business that essentially you are now a software company working in the healthcare space, or a software company working in the finance space. And a lot of the challenges derive out of trying to apply kind of the old way of doing things with kind of the new realities. And one of the biggest things that we see coming out is not just having all these applications to juggle, internal line of business specific developed apps that support backroom processes or SaaS programs or websites, but also the tremendous amount of data that comes out of these things. They collect lots and lots of data, and kind of by default, just kind of end up storing it and don't really know what to do with it, because depending on how it's set up, it might be structured, might be unstructured, and it's going to be in silos and all these other things. So, how do we deal with all this stuff? So data, a lot of times, ends up being kind of a modernization trigger. So what we're calling modernization triggers is, we have to either get more functionality out of our current stuff, or we have to, upgrade because data center contracts are expiring, or we have security threats, right? We maybe have, an old table in some sort of data store that is storing passwords unprotected, because that's how it was, 20 years ago when the system was built. Now, as Michael mentioned, there's a couple different things. It's not just modernization. There's going to be two things I'm going to talk about. One is migration, and one is modernization. Migration is kind of more like a lift and shift. It's basically moving workloads from where they are now to the cloud. So migration is going to be the quickest way to get benefits, because you're going to instantly, get back a lot of those headaches that you have from supporting, data centers and, all these compliance and management of all this infrastructure, just by shifting those workloads from on-prem into the cloud. And those migration triggers are going to be consolidation of data centers, hardware refresh, and or just general, direction to move away from on-prem systems. So, maybe you want to, not have such a large infrastructure support or operations organization. You want to, repurpose some of those resources and be able to, add more functionality or do more development and innovation. So just by lifting and shifting those workloads, you can manage that stuff. Now, the key with migration is to consider kind of the benefits and challenges of moving from a CapEx model to an OpEx model. So a CapEx model is kind of traditionally how hardware and infrastructure was handled. You buy a big ESX host and buy a bunch of servers and buy a bunch of VMware licenses and get everything set up, and you have a one-time cost, $200,000, $500,000, whatever that is, and then over time, it depreciates to basically nothing, as you kind of use that equipment, over the long term. So essentially, you just have to pay the big lump up front, and then it gets cheaper and cheaper every year. The cloud model is a little bit different, and it can be a little bit misleading because, instead of a big $500,000 lump up front, you might only pay $5,000 a month for the same workloads. And you might say, that's great, we're going to save so much money, because you're just looking at that. But you have to remember that then continues basically to perpetuity. So it's not a bad thing, it's just a shift in how you look at how those dollars are spent. Now, modernization is what's going to require more effort. Modernization is not going to be just, hey, we're going to move, all of our Citrix on-prem servers to VMs in the cloud and flip switch. Modernization is something more like, we need to deliver stuff faster. We need more features. We have, legacy outdated code that we want to, add new functionality to, and we want to innovate. Those kind of things require more effort. You have to, probably write some new code. You might have to, introduce new parts of a system. You might have to, get things out of old languages like, maybe mainframe languages, COBOL and things like that, and into modern languages, C#, Java, depending on your preference, so that you can start to take advantage of some of these newer features and new capabilities. And modernization also requires that you have to have access to that code, or at least an API layer within that application. Otherwise, it's not going to be just modernizing an app. It's going to be a rebuild at that point. All right, so applications are made up of three distinct concerns. There's the code layer, which is basically the functionality and all the business logic. Then there's the data layer, and this is basically all the data that the application consumes and generates and runs on, and all of its different sources. And then there's the infrastructure. And infrastructure is, either virtualized or the machines that it's physically running on, all the networking and all of that. Now, when you modernize an application, you're going to have to look at each of these concerns. Each concern will be addressed separately and in a slightly different manner. For example, a lot of the times the pattern that I see, especially with larger enterprise clients, is they say, let's virtualize all the infrastructure. We can, go containers, go VMs, whatever. We'll get that all in the cloud, and with the code, we'll rewrite that, get it all, modernized, maybe even go microservices, really small scale, and get all this deployment and all this cool DevOps stuff. But all the data is going to stay on-prem in one giant database, because either A, we have a massive contract that we can't get out from under, either with like an Oracle or a SQL Server or some other data store, or there is a a real aversion to privacy concerns, moving any sort of data to the cloud. So that seems to be a pretty ubiquitous pattern, just because moving code and infrastructure, those are easy sells as far as modernization goes, because it's easy to see those benefits, and it's, for the most part, relatively lower risk. Moving data has implications, especially if you deal with any of the P datas, right? The PII, PHI, PCI, any of those protected data types. Then it has to be a much more thought out process. It can't just be, hey, we're just going to move this there. Then you have to think about, okay, what are the encryption levels? How do I, make sure that everything is, encrypted at rest, encrypted in flight, and what are my protections in the cloud, and do I trust them enough to actually move? So usually the way this works is you kind of go through this pattern where you start with the infrastructure and say, okay, first thing we're going to do is look at, let's virtualize or cloudify all of our infrastructure stuff, because that seems like an easy way to get things into the cloud. Then you make that data decision. Okay, are we going to have data here, or are we going to be able to migrate data to some cloud data stores? And whichever way it is, that you want to get those things stable before you start adding code on top. So infrastructure obviously has to be in place and has to be solid before you can start to add stuff on top of it. Data, you want to have that decision made and solidified before you start trying to modernize any application code. Just because if you have to repoint and if there's maybe some crossing, you want to have all those concerns figured out before you start actually writing code, because otherwise you can end up trying to put toothpaste back in the tube a little bit. All right. So some of the challenges here is, a lot of times most applications have prior application investments, right? You have huge things that are outdated, inflexible, maybe not up to the task, just because maybe your business environment changed. How you used to do business when the company was founded, or how the company used to do business when the company started, may have evolved or changed completely. Especially now, think about how things have had to adapt and how things have had to change with social distancing and some of the stay-at-home orders. And in order to kind of adapt at that rigorous pace of everything's normal-ish to now nobody can go outside, kind of overnight, it makes it really hard if you have a lot of legacy stuff that's kind of baked in place in these old processes that require, dependencies on things that just essentially disappear overnight. So it's kind of the difference between being able to steer a motorboat and being able to try and steer a big cruise ship. One is slow, one can be really quick. And like Michael mentioned too, most IT businesses most IT budgets are consumed with maintaining these existing apps, keeping the lights on, keeping these old systems running, and especially legacy ones, right? Because a lot of times these legacy apps, especially if they're in mainframe or older languages, maybe they're VB or VBA or something that is not as modern, but worked for the time. A lot of times the people who worked on those applications initially may not even be with the organization anymore. And depending on levels of documentation, you might end up having essentially like a whole suite of black box type of applications that, you don't really know what they do, but if you turn them off, bad things happen. And then, getting out from under the weight of all this legacy stuff, all this code, all this, data silos, all these, old different versions. Maybe you have some new stuff, maybe you have some old stuff, and trying to get out from under all that can be a huge task because number one, at most companies, schedule is going to be king. So you could say, we're going to modernize all of our applications as long as we finish at this sprint, right? So that becomes a challenge. And then, you also have to realize that a lot of times migration and modernization often have to come at the expense of business needs. So that is, just because of a resourcing issue, because you don't have infinite resources who can just say, okay, I'm going to take the next 3 months off and, rewrite our applications in a new framework or help to modernize them. Or, I have, we don't need any new features for the next half a year, so you guys go ahead and fix all the technical debt in the code. It's usually not the case, but this is where things like Azure can really help. And there's a way that, we can, as you start to enter these processes, we can help kind of future-proof the code. So as you move into this digital space, you want to make sure that you evaluate and make sure that you're ready to move to the next level, right? So chances are today kind of looks like the today side for a lot of folks, right? So kind of this fixed scale servers, infrastructure, data, multiple disparate locations and shapes, siloing, limited set of platforms and form factors. And I see this a lot with clients too, especially if they've been around for a while. They tend to have kind of what I would call more of a traditional like solution architecture organization setup, where they have, they want more or less like design documents and kind of like a detailed plan of how everything's going to work, who's going to support it, how much capacity you need. A lot of these things, kind of defined up front so that they can design and support and move things through kind of their existing machinery. Now that's great, and that works for a lot of organizations, especially enterprise organizations. The challenge is those organizations really struggle with innovation, because it's really hard to kind of step out of the box and make, kind of these quantum leaps and drive a lot more value when all you can use is the approved set of, applications and platforms, regardless if there's something else better out there for what you're trying to do. Or if you do want to use something else, then you have to go through the approval process and, the vetting process and some of these, more aggressive planning processes that by the time you're completed, that technology might be already on the outs and there's a new technology that's taken its place. So, you kind of want to have a balance with the two. So a lot of times what I've seen larger companies do is, kind of keep the status quo for most of those key business drivers, right? The ones that keep the lights on, right? Got to have those processes in place, because if something goes wrong with those, it could, negatively affect the company. Now, what you want to do is what they want to do is then target a specific area that is, ripe for innovation, right? Maybe there's an employee process, or maybe there's a new revenue stream that we can't take advantage of right now, but if we kind of, set a team up and kind of let them loose with some of these newer applications and opportunities, they could kind of drive and maybe build out some new patterns so that we could have kind of this blend of both. And, with that future, you get, moving to the cloud, you get a lot of those things that that kind of help address some of those needs, like elastic unlimited scale, right? Multiple platforms and devices and form factors. So, you get a lot of this kind of out of the box. So those questions of, who's going to be accessing it, how many users, you don't have to have all that nailed down in stone. You just have to have a rough idea, because you can scale in the future and it's going to be a lot easier to support everybody. You're not going to have to rewrite applications to work on different different form factors. So now, like I said, a lot of times companies are dealing with infrastructure that's really complex, that's grown over decades, and they have to support multiple platforms, tons of different types of data, all this legacy stuff, and it causes kind of a lot of uncertainty and questions about how to get to the cloud and get some of this promised pain relief. So let's talk about kind of the different paths on the journey to the cloud here. So the first one is a strategic activity, and that's modernizing an application portfolio. So it's a process of not just understanding a single app and making a plan to get it, but it's understanding all of your current applications, data assets, and their relationship to business functions. The goal is to determine where the current suite of applications fits in the long-term strategy and how well it supports the evolving business models. So you want to kind of look at not only what you have and say, okay, I just need to move this to the cloud, how do I get there? But also do a rationalization exercise where you look at all the things that you have and say, okay, does this even work anymore with our new business model? Or is there a better way to do this? Or can this just be a migration activity where we just need to get off this mainframe, that's costing us a lot of money, for MIPS? Can we just, migrate the workloads somehow to commodity hardware in the cloud so that we can just save on those costs? Now, it's like I said, it's tempting to just start moving applications, boom, 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 and say, all right, we're there. And, there's all kinds of like semi-automated tooling sets where you can just push a button and kind of say, okay, now your apps are running in the cloud. The challenge with that is, a lot of times you can end up just kind of not only lifting and shifting your applications, but you can also lift and shift a lot of your issues. And because if you're not addressing any of the issues when you go over there, they're just going to be moved now into maybe a space where you have less experience on how to troubleshoot them. But the key is to just take a little bit more of a strategic approach, because it's possible to modernize a whole portfolio of apps in a way that gets you the most value at the lowest cost and makes it a lot less expensive to stay current and for your applications to evolve. So, like I said, going through this assessment phase is really crucial. So the first three are the assessment: assess, prioritize, and plan. Those are the strategic activities where you go through, look at the applications you have, identify them, and prioritize them based on their business impact, right? So, is this a critical business application? Like if this shuts down, are we going to shut down? Then make a plan to kind of migrate it from there. The last activity of execute, where you actually are going to retire, replace, migrate, modernize, rebuild, or rewrite, that's the tactical activity. in order for that tactical activity to be a success, the strategic activity has to happen. So, and the other thing to think about is most of the applications that were built and that were, in your current suite were implemented to meet a tactical need, right? Oh, we need an HR system. Let's buy this one. Okay, we need a payroll system. Well, this one has a suite, suite mate. Let's buy this. Or we need something to track one of our internal processes that we're doing by hand. Hey, we can rewrite that. So you end up with this hodgepodge of things. And so doing the assessment kind of helps you see the holistic value of everything, and not just its value, but its technical characteristics. If it has any sort of interesting dependencies that you may not know, and kind of vet all those things out before you address this and get to that tactical activity where you're trying to make these applications better or move them to the cloud, and then you realize there's no way for me to do it because it's dependent on a system that only runs on John's laptop or something. Now, doing this activity will help drive more value out of your application modernization activities than just picking the lowest common denominator ones and modernizing those first. So as you go through this, what you'll find, and Michael did touch on this a little bit at the beginning, but what you'll find and what I've seen is, right out of the gate, you'll find about 5% or 30%, that you can take out behind the shed and, just totally get rid of. Just shoot them right in the head. These applications are dead. They don't do any purpose, in our new business. They're old, or they've been replaced by something and we didn't know it until we actually looked at it. So just going through this exercise of the assessment of your application portfolio, you'll find that, hey, you know what? This application is redundant because we bought a SaaS or a COTS product that actually does this same activity, or it no longer pertains. We no longer, deal with this process just because of how the business evolved, or it never worked, or it's been off. You might find a bunch of dead code. Definitely seen that. We're working with a fairly large company right now that's doing a huge modernization effort, and they have been running this giant monolithic application for years. It runs their business, right? Well, as we're modernizing, they're going through, and of the 100,000 different modules and applications, they've been able to eliminate more than 30%, more like about 40 or 50% of these applications, because they were written for one-off things and just kind of tossed into the pile. And, that one-off thing went away when they either fixed the issue or modernized the process. So, that's kind of how monoliths evolve, is they end up being like a giant snowball and rolling downhill and getting bigger and bigger and bigger. And what they are at their core and what they really need to do is probably different than what they become. The next bit you'll look at as you go down is you'll say, you know what? We, beyond the ones that we can just get rid of, now we have another like 15% that we can almost immediately just replace with a SaaS or a PaaS party. So one of the big ones is, the Office, whole Exchange servers, all that on-prem Microsoft Office infrastructure that a lot of companies have. Just move it to O365 and the online stuff. That's pretty straightforward, and we see that a lot. In fact, a lot of the growth of the Azure cloud is due to that adoption of Office O365. It's now just called Microsoft 365, I think. But it's, just moving to that suite then gets all, there's no longer someone watching an Exchange server to make sure that it's not being overloaded. There's, no one, making sure that, PowerPoint, you have the right PowerPoint installed and that your machine has the capabilities and all the software. Once you have O365, it's all becomes a cloud managed SaaS product. So that's one of the things we see pretty often. Now, the last bit, this is the kind of the sweet spot. These about the next chunk you have where you can actually move doing the modernization activities. So converting, to an Azure PaaS solution, optimizing for Azure using an IaaS, or just lift and shift to an IaaS. So a lot of these are going to be your kind of in-house custom-built applications, web apps, portals, anything that you've like custom built to handle something. Those can really lend themselves well. Now some of them can be really difficult to move, and some of these could be like legacy source control. Maybe you have an old CVS repo or something that is going to be hard to migrate and get into Git or TFS or VSTS or one of the online or cloud-based applications. So those tend to be the last things that you move, but you'll get almost 50% of your application portfolio will have some sort of story, either to migrate, where it's going to be, hey, we're going to move this workload from on-prem into cloud, or modernize, where you can actually say, okay, we're going to add value, we're going to leverage some PaaS, we're going to leverage some of these services that are built into Azure to add value, and migrate those. And then, like I said, there is always going to be a percentage of applications that just are too expensive or too risky to move off premise. And a lot of times these tend to be some legacy data store or even some legacy applications. Maybe there is something that only runs in a mainframe and can't be moved. It might have a life cycle. It might have an arc, but for example, one of my clients worked on a legacy application. I think it was in a giant VBA app. And they're like, you know what? This is end of life. We've already got an actual Azure application that replaces it, except we still have projects on this application. So end of life means it will at least be around for the next 6 years. So we can't move it because it's critical to the day-to-day. But we've already modernized the functionality of it and have a replacement. So all new projects are getting on that, but we still have to support the existing. And it just doesn't make sense to try and shoehorn those existing ones into the on-prem just because of the risk, when you can just have that landing. So if that makes sense. So one of the things that Microsoft does, which I really like, is they've created this this analogy here about how to think of some of the services that are available as you look at modernizing. So IaaS, this is basically, hey, I want VMs and I want compute. I basically want to migrate and lift and shift my workloads. That's akin to owning your own home, right? So I'm going to take it and move it, but I own the whole thing. So if the plumbing breaks, if the house needs paint, if something goes wrong, it's all on me to fix it. For the most part, I might have a contractor that comes in, but all what goes on in the house is basically up to me. So I have total control to do whatever I want, but I also have total control to do whatever I have to do. So, that's all the responsibility. Now, as you migrate up, you go into platform as a service. So platform as a service is like a bed and breakfast for your applications. So this is, you move in, things are handled for you. You kind of just lean back and enjoy your breakfast. So this is, like app services, web services, things that, hey, all this other stuff kind of behind the scenes is, handled for me. I just have to bring myself and my content kind of to the table, and it handles it. I kind of have to know, just where I want to stay and some of these other basics, but it's a nice experience. And then taking that one level up is serverless, and serverless is like a luxury hotel where you really don't have to think about anything except for you. So you don't have to think about, what are all the bits and what is all the interconnections and what's all the infrastructure and what about uptime and do I have to have redundancy? You don't think about any of that. You just say, I need to think about this particular function. So Azure Functions would be a serverless. I just need to think about this particular application function and put it up there, and then it's available, and then it's up, and it gets activated every time I use it. But I don't have to think about anything. So owning your own home is IaaS. PaaS is bed and breakfast, and then serverless is like a luxury hotel. So everything is all set up for you. Okay, so one of the top 3 takeaways, and Microsoft, went through this activity themselves, and so this is some of their top 3 takeaways, and also from some of my experience going through these modernization activities with clients. Number 1, like I mentioned, it's a great opportunity to clean house. So, a lot of times things hang on way longer than they should just because, you don't have time to look under the covers and see what's actually going on. This opportunity where you go through and, rationalize and assess and prioritize all these applications that you want to modernize allows you to shine lights in those dark corners and say, what's this thing? Oh, that was something that Bob wrote 20 years ago to handle import when the FTP server was down. Okay, do we need it anymore? No, we haven't used that in 20 years. Right, okay, gone. That will really help. And then, also doing that, hey, we have all these custom pieces. We're actually moving to Salesforce. Salesforce can handle all these custom pieces, and they do it in an industry standard way, and we can kind of get out of the business of, building our own CRM or whatever. Perfect. Let's do that. The other thing is don't take any of the hosting models off the table too early. So just because IaaS, can be, don't take it off the table, even though a lot of times you have to go through a little bit more of an activity of assessment to ensure that it's a migration strategy and not a modernization one. Don't take it off the table because IaaS is one of the quickest ways to kind of get value out of the cloud. Definitely don't take PaaS or SaaS, the serverless or the platform as a service stuff off the table too early, because it is going to add a whole lot of value, and those are the things that are going to kind of future-proof your application going forward. And then move applications in stages, right? So like was mentioned, those simple workloads, move those directly to those to the bed and breakfast paths, right? Websites, static portals, standard 3-tiered layered apps. Move the complex ones, you can move those in phases, right? So if you have something that is really complex, you want to modernize and you want to get it off the on-prem stuff, move it into an IaaS first. Then at least you're in the cloud, and then you can start to kind of pull off those pieces and abstract and dissolve away the functionality that you want and modernize it in a phased approach as opposed to a big bang. But getting it into the cloud first is a lot of times, kind of that big hurdle. Once it's there, you get to unlock a lot of the benefits. And then, a lot of the black box undocumented legacy code that you have to keep, either keep it in place. One of the best things that we've seen to modernize these, kind of legacy apps is to add new functionality using serverless. So, mainframe or, these really old monolithic applications that, you can't just move, or, pulling them apart is going to be a huge effort. And, you still have to add, functionality to it, because it's what's keeping the lights on. And, like I said, schedule is king. So the business says we still need to have new functionality out of this. You don't want to go in and add more technical debt to the monolith. Abstract that out, put it in a serverless function, and then have the application call out to that serverless function. So number one, you're keeping your code closed for modernization, right? That monolith, you can start to encapsulate that and kind of, push it away, and you're putting new functionality in a serverless, workload. So once you do get the chance to modernize those bits a little bit more, the new functionality is already in the space where you're going. All right, so modernization. So this is kind of what we've been talking, the difference between modernization and migration. So Azure is, pretty much a turnkey platform for application modernization. So, and this is, keeping kind of in line with a lot of the Microsoft way. So as opposed to AWS, which is more of like a kind of a Chinese menu type thing, where you say, okay, I want some of this, I want some of this, and I want some of this, and then they all give it for you. Azure really is, a true platform. So now lift and shift can be viable for, a lot of applications. It's not going to unlock all the cloud benefits. Now, if you want to get the most, that's where you're going to do modernization, right? This is where you're going to get things like agility, cloud native, improved resilience, global scale, all these cool things, performance improvements, all the stuff that you know and love, about the cloud. They're, microservices, managed services, and, continuous delivery. You can do all these things. So Azure gives you kind of that turnkey platform because it offers a really broad range of managed services for just about every application scenario. So, if you do want to move your data loads to the cloud, there's, managed Azure data stores for that, which, can be really huge. I don't know if you've ever had to deal with, working with DBAs or DBA organizations, maintaining these huge enterprise data stores, but, getting any changes or, getting new indexes or, getting, these performance tuning bits, a lot of times can be like pulling teeth, because I'm pretty sure most DBA's default answer to any question is no. And then, after the second or third round, it becomes no, but maybe, right? So moving it to a managed instance, you no longer have to worry about, a lot of those things. You're more concerned with, do I have the right data in the right places? Just as an example. The other things you get, containerization, orchestration, all these kind of advanced things, cloud native apps. You don't have to provision and manage all the infrastructure. I don't know. One of the things that happens in modernization activities is people start to, say, great, we're going to take this giant monolith and we're going to break it into 1 million pieces, right? Because that's microservices, all right. And we're going to spit it all out and we're going to have 1 million apps. Well, now, all these other concerns that were handled in proc like service to service communication and fault tolerance and some of those things are now in the DevOps space. And maybe that's a skill set that you don't have, or maybe it's one that you're just learning, or maybe you don't have the right tooling. So then you have to prop up all this additional infrastructure that you never really knew you needed. Moving those to the cloud and into managed services like AKS, managed Kubernetes. I mean, that can be a dream for some of these modernization activities. So one of the things you want to look at is when you are looking at these different options is look at productivity versus infrastructure control and the level of infrastructure abstraction. If you want to focus on code and application functionality first, without having to think about the underlying infrastructure, then serverless and platform can be right for you. On the other hand, if you want to have tighter control, then maybe things like containers and Kubernetes could be the best choice, because then you can control OS and environments in those kind of micro scales. So, and it could be a combination of all those. So just think about that. Okay, now when you modernize with managed services, some of the most common business challenges we see is when all these self-hosted applications that people have, or websites, they can be addressed almost immediately just by moving to managed services. Keeping these applications up and running 24/7, guaranteeing consistent level of performance can be a challenge, internally, especially depending on, age of the hardware, availability of resources, and if, for example, you have a marketing website or you have a marketing initiative and you want to make sure that it's up because it's, maybe key for the business, a lot of times, depending on how the infrastructure is set up, there might be an outage, there might be, there might be a planned outage, there might be, some other resource contention that's causing the site to slow down. Moving to the managed services then allows the business and everybody to kind of just take a break from all those, worrying about all those things, to worrying about what are we actually putting out, and is it the right stuff, and worrying about the content and the applications themselves. A lot of times, not just beyond just like the static stuff, but think about, some smaller, like 3-tiered applications. A lot of times, some of those deployments are not automated, or they're slow. You might be doing X copies, and then you have to like repoint IIS and all kinds of other things. Moving, to those managed services, again, solves a lot of those things. So, it's hard to, one of the biggest challenges, at least that I see, especially with places trying to implement containerization that are not in the cloud, like they want to have a on-prem container instance, like a Kubernetes or Docker Swarm or something like that, is trouble replicating those sort of infrastructures on developer machines. How do I replicate the entire swarm on my developer machine, or can I deploy to a dev environment? And is it different? Is there any sort of opinions in the build system that I'm not aware of? Some of those challenges. Now, when you move to like I said, EKS or some of these managed services, everybody's working in the cloud, right? So even like developers, right? Your developer environment a lot of times is, kind of coupled with the cloud. So as you move through, you're already in that space, and it makes it a lot easier to kind of go through. So let's kind of on that line, let's talk a little bit, about containers. So containers can be a quick option for a no-code app modernization, right? So now, while VMs modernize the machine itself, containers modernize, or VMs abstract the infrastructure while containers abstract the OS. So what this allows is, a much smaller footprint than a VM, because you don't have to have a whole copy of the OS. It all just kind of sits on top of whatever OS. So you really are just focusing on what are the things that your application needs to run. This really, can leverage, can enable developers to get things up to speed really quick, because they can kind of build out everything that they need, build out their container image and say, this is exactly how I expect it to work. And, these are all the things that I need. You deploy all that, as code, and it moves through, and, things get deployed and get working really good. There's also, really kind of advanced integrated CI/CD tooling and orchestration. So this is, the Azure Container Registry, and then like AKS. So some of those, by managing and abstracting all those things, you can get a pretty big bang for the buck without, having those large footprints of VMs, just by moving to containers. So that's definitely one thing to think about. The other one, and this is one of my favorites, is microservices. So now, re-architecting with microservices, this is where you essentially take your monolith app and you break it down into kind of these units of work and create microservices or mini services, basically, depending on the size. So like I mentioned before, the worst thing you can do is break it down to 1 million pieces, and you don't want it to be 1 million, you don't want it to be 1. There's going to be some, somewhere in between is going to be the best. The nice thing about microservices is it allows you to do a lot of things that you can't do with a monolith. So number one, with microservices, you get those deployment. Deployment and scalability are usually the two pain points that people say, hey, we got to start breaking this thing up. Number one, deployment might be an 8-hour activity where you get everybody in the office and some pizzas, and you start at 10 at night, and you guys are done by the next morning, right? Because it's this huge application with all these libraries, has to be moved manually potentially to all these different servers, and then it has to be validated, manually, because it's just this huge beast. With microservices, you can split those up into their smaller pieces and start to automate, deployments, and then the key is they're loosely coupled via dumb protocols like HTTP or HTTPS, and, they just communicate that way. So then you get this ability to kind of isolate things in, really their own space. When you do that, then services can be taken down and spun back up. They can be tested individually, right? So think about another deployment woe is, what if somebody accidentally turns on run all unit tests on the build? If you have a giant app, it could take hours to complete that. This way, by moving the surface area down to these smaller units, testing becomes a lot more feasible, and then it gives you a little bit more comfort, because you can say, hey, we test things before they go out to production, right? We're not just using faith-based testing and hoping that things are going to work out good. And then by breaking it up like that too, developers work on smaller units. They can be focused and just focus their knowledge on the specific service, and those bits of your application that are potentially needy in terms of resources can be scaled individually. So scalability of the monolith really is only one story. It's a vertical scale, right? You can bigger machine, more memory, start jamming Fusion IO cards into the database server, whatever. With microservices, you have the ability, to potentially, instead of having, one giant application running, you could have, 50 versions of the same application handling calls in a round-robin fashion. So it gives you a lot more ability to handle workloads of your system within your system, as opposed to having to scale up the big one. Okay. All right. And then, like I said, one of the more fun ones, and one of the ones that I've been working a lot with recently is serverless. So serverless, and especially with Azure, you can build apps without provisioning or managing infrastructure at all, using a fully managed platform, and scaling, availability, performance is all handled for you. So in this model, Azure dynamically manages the allocation of the machine resources, and pricing of this is usually based on a consumption model. So as resources are consumed, as the function is fired off and as it does its thing, then you get a charge, as opposed to having a VM that is essentially running all the time, or container instance, right? Which is, potentially running all the time, that is, potentially constantly billing. This will only run based on when it gets fired off. So, and like I mentioned before, implementing serverless applications is a great way to kind of extend functionality to existing legacy applications without having to go in and try to modify any of the code. You can kind of encapsulate that as a point in time application and then extend it using serverless. Now, there is some caution here, right? So with anything, you want to go through at least, some sort of design process when you think about modernizing things. So we had one client that, decided that they wanted to go with serverless for everything. So they broke down their entire application to being, just a web front end, that all it did, the entire service layer, was Azure functions. And, by breaking it up into those individual functions, they quickly found that, instead of having, one or two, units, they had 50 functions. And a lot of times these functions, either had config or things that they had to pass around, so that if they changed something, then, they had to go through and edit 50 functions. Also, even though they only worked on a consumption model, a lot of times some of those were actually really heavily used, and it ended up being more expensive than just decomposing those functions back down into just a couple containers or web apps that handled most of the web load, because it's just one of those things. So the danger with functions and serverless is it's really easy to functionally decompose your whole system. Say, hey, I want something to do this, I'm going to build something to do that. I want something to do this, I'm going to build something to do that, and you end up with this giant Frankenstein of an application. Now, like I said, it can be good, and it's really, really good to add those little bits of application functionality, especially to new stuff. But as it starts to grow and grow and grow, and your footprint grows, maybe move it to a managed service, and just kind of collapse it down into, instead of going these individual functions, maybe it actually becomes a microservice at that point. But all kinds of cool stuff that can be done with serverless. One of the other big things that you get with Azure is DevOps. Now, this is another on-brand Microsoft thing. DevOps is actually kind of like a process, and it's like a name for something, right? So it stands for it's a blend of developer and operations, right? So all these tasks around deployment and APM and CI/CD and all those things is kind of what DevOps stands for. Microsoft renamed their DevOps suite Azure DevOps. So it can kind of get confusing when you're talking about DevOps. Are you talking about the program, or are you talking about the concept? So in this case, we're talking about the program. So Azure DevOps. Okay. Azure. I'm getting an echo here. I'm gonna turn this off and then. Okay. Azure DevOps allows you to basically go through the whole process of the DevOps continuum, right? So with Azure boards, this is kind of like, it blends a lot of the old TFS boards, and think about if you've used Jira and some of those boards, just that kind of agile, Kanban board style that you're kind of used to. So you get that plan, you get develop, so you get integration with Visual Studio and Visual Studio Code. Collaborate, now all the repos themselves are actually Git based. So you get this GitHub functionality, and with Microsoft purchasing Git recently, there's going to be a lot more integration of some of those functions going forward. And then deliver, right? You get pipelines, test plans, and artifacts. And then, one of the things that you can do with this is you can create ARM templates, which allow you to, kind of recreate these things over and over and over. And then operate. You get, that APM that we talked about, that application performance monitoring. You get to monitor your workloads and make sure that everything is working good. So you get a place to store your code, place to collaborate and do code reviews and, pull requests. You get a place to track all of your work. You get a place, to, deploy all your work, CI/CD, with gated check-ins and all kinds of pipelines. And you get a place to actually monitor how things are going. So DevOps can actually, kind of take, especially if any of these are pain points, they can take, existing applications, and just by putting them into this process, alleviate a lot of those. Okay, so in closing here, so to make a long story endless, I'm going to keep talking, but one of the things that we've definitely seen is, a lot of times people can lower their total cost of ownership just by moving to Azure. Now these are all coming from the Azure calculator and from Microsoft. So just by migrating data centers instead of on-prem, you can get a pretty big savings. Now, a lot of times that's because, I don't know if you've ever migrated data centers in the past, but when I've done it, it's been a Herculean effort to do some of these things, because it's not just physical machines you have to worry about. It's secure access, and do we have enough bandwidth going in and out, and what's the availability and what's the redundancy? Can we have one? No, chances are we probably have to have three. So then moving that into the cloud then takes all of those extraneous things out. You do get a substantial savings by rehosting apps, just on PaaS, right? So getting things out of, again, a lot of this is going to be infrastructure and maintenance stuff that you move and save the money, because you don't have to pay somebody to care and feed it. Now, architecting, notice it's a little bit lower, but that's just because there is an effort involved. It's not just, okay, I'm gonna, move this here. Instead of hosting this internally, we're gonna host it on, as an Azure web app. It's, we're gonna take this app, and in order for it to function, we're gonna actually make some changes to it so that it can take advantage of all the things that Azure has. And for the most part, I mean, Azure's been doing a pretty competitive job against AWS, and on average you're going to save 5 times, and it's going to be 5 times lower cost for the workloads, for Microsoft workloads compared to AWS. So even though AWS does everything, Microsoft is obviously going to be keyed in on that. So one of the last things, this is kind of like that checklist, and kind of gives you an idea of where it fits. Is you want that rapid time to the cloud, you want to free up data space. Some of these really quick things, those are going to be lift and shift. Refactor, where you're going to be maybe changing to take advantage of PaaS. That's going to be business agility stuff. Moving to DevOps. Maybe integrate with other web apps. And then, you want to get those new breakthrough capabilities. You want to get, maybe some multi-channel access, mobile IoT. Those are going to be rebuilds, but you can still use PaaS for that. So kind of to sum up, we've talked about how existing and new applications can tap in kind of to the power of the cloud and Azure specifically, kind of at a high level. And this session was really designed as kind of like the first of many, and if anybody wants to, we can definitely go deeper on any of this stuff. And, I know we will in some of the other talks talk about a couple things specifically, but I will tee it up and pass it along to Derek Andre, who will be talking about AI and cognitive services. Derek, are you there?
Hey, everybody. Welcome to my house. So yeah, today I'm going to be talking about machine learning with Azure Cognitive Services. As Dallas said, my name is Derek Andre, and I'm a software consultant and certified Azure developer with Keyhole Software. You can check us out at keyholesoftware.com. Personal plug, we have lots of blog posts and things like that about all sorts of software topics. I've written about Azure Cognitive Services and other machine learning things. So you can check it out, keyholesoftware.com. So, and if you're following along at home, they have a presentation guide with my kind of presentation here. But if you want to look at the code, I'm going to have a demo Xamarin app. And if you want to follow along with the code or anything like that, it's available here on GitHub. And so you can check out the code. Also, my presentation is there if you want to check that out. Okay, so what are we talking about today? We're going to be talking about Azure Cognitive Services, what it is, the APIs that are available, how to use them. I'm really going to focus on kind of two of the many APIs, mainly the computer vision API that's part of the encompassing vision API, and then I'm going to talk about the content moderator API. And I'm going to do that. I built a little Xamarin app, and we're going to just go through that, demo that, go through some of the code, see how easy it is to use this. They use Azure Cognitive Services. So what are Azure Cognitive Services? Basically, it's AI as a service. So if you aren't, acquiring like a machine learning company, if that's not in the budget, then, you can use these, simple APIs, and you can get really cool insights about like the content going through your apps, like, in your images or in your text that people are posting. You can find out kind of look into it without actually, having people look over all this stuff. Like another cool thing, obviously, the stuff is run in Azure, but they also make Docker containers where, let's say you have some kind of on-prem solution or something like that, and or you have some kind of, other solution other than having it in the cloud on Azure, then you can run these in a Docker container. So that's pretty cool. One thing to know is you're not getting this stuff for free. It will phone home and still account against your billing. Also, these services are very they're secure, they're compliant. Things like HIPAA, they have their HIPAA PAA. Also, they've been adding these cognitive services to more regions. So for security, if your data, it'll be real close to your Azure Cognitive Service region. So that's nice. All right, moving on. So what's available? What can we do? Azure Cognitive Services, they kind of have 5 main kind of categories, and you can see them here. There's decision, language, speech, vision, and then, the Bing stuff, the Bing search. Okay, so there's 5 categories: the decision, language, speech, vision, and then the Bing stuff. So I'm going to be talking today decision and vision. As I said before, the content moderator APIs. This API is going to kind of handle things like, hey, are your videos, images, or text, do they have racy content in it? I know that's very subjective, but, kind of like, is there adult content, racy content, bad language? The content moderator does stuff, things like, is there personal, identifiable information and PII and stuff like that. That's the content moderator API. I'll go into a little more about that in a minute. Other things with decision anomaly detector. If you have like series data or something, you have a device or something, you're logging a bunch of data, and anomaly detector can it'll take that data in, and it'll alert you and things like that if something's out of whack. An example would be something like if you have like a water pressure alarm. These are cool new devices. They actually hook up to the water input pipe in your house, and then it'll detect like if you have a leak or something like that. So, and then personalizer is interesting API. It will if you can send it like say an image or something, and you can have a collection of images, and it will display. You can display this content on like your web app or something like that, and then it will kind of detect how a user interacts with it and things like that, and it'll give a ranking, and then it will kind of keep track of like what's working and what's not, so to speak. Moving on to language, things like immersive reader is actually an interesting thing. It will actually display, really, I think it's just an iframe, and it will display kind of what the text that you're looking at, and it will like help people. It'll translate things. It will show like image representations of words. It'll highlight things like nouns and things like that. So that's pretty cool. The language understanding APIs, think things like chatbots, kind of coming up with, conversational, answers to questions and things like that. Also Q&A maker. Q&A maker is something where you have kind of static data, and it'll give you, for a question, it'll give you an answer. Text analytics will go through looking at like the intent of words, natural language processing, things like that, and translator text obviously will translate text. The speech stuff, you can get back audio files, or if you have something, like you have an audio file, you send it up, you can get the text out of it, vice versa. Translation, computer vision. I'll be looking at the computer vision API, but basically like, hey, what's in this image? What are the objects? Is there anything, adult or racy or anything like that in there? Face detection. Hey, are there faces in there? Where are the faces? How many faces are there? You can, I wrote a blog post on capturing, training an Azure face model to detect, you can train it to detect people. So, I have it had to detect myself. And so it'll detect faces, and it will alert you if it knows who that person is. Also like things like celebrities and things like that, it'll detect. And then form and ink recognition, hey, I have this, document a customer filled out, what's in the form. And then the video indexer is really cool. And you might have seen it. There's a Microsoft commercial where there's like, this like science group, and they're, tracking snow leopard, population count. And so, video indexer will look through video and pick out text and, what's in the video frames, and, and things like that. And then the Bing stuff, using Bing to do, web searches, or, finding news articles compared to what your query is, or searching with images and things like that. So lots of stuff here. So moving on here. So what can the Vision API do for us here? So, the Vision API can, as I said before, it can detect faces and like what's in your picture. Like, oh, you have a table full of, whatever. You have a can of soda or things like that, or there's flowers. The cool thing about the computer vision API is it can detect things like brands. So like, let's say you have a brand and like a logo or something, and you're like, hey, are people posting pictures of my logo. Maybe I have a contest where it's like, hey, post a picture of my logo and you win something. Or hey, my competitor's logo is in your picture. You're banned for life or something like that. So, and they'll do like landmarks and things like that, and celebrities. I'll show that off in my app. Here is a little snippet from the computer vision API, just to kind of get you warmed up for what we'll be seeing. But yeah, I mean, it has all sorts of data, and this is just a snippet. It's quite extensive, but has things like is it adult content, is racy, and then the description tags is an interesting part of this JSON snippet. This is where it will start to tell you like the objects in your image, and then it's like, okay, that's very interesting. Like, okay, well, this person is posting objects, these objects, and there's a whole slew of what you can do with that. So before I move on, I just wanted to go back and talk about things like the form recognition API. I've had clients that were interested in this, and it is really cool. Basically, think of like some kind of form you would fill out, like a W-2 or something like that. You have an image of it, and it will kind of extract like where it is in the form, and it'll extract like answers and things like that, and then so that's pretty powerful. Also, it has digital ink recognition, so think of things like handwriting or stuff like that. It will recognize that and turn that into text that you could read. So things like maybe like check scanning and things like that. Think of stuff like that. And then the video indexer was very interesting. Basically you upload videos and it magically gives you all sorts of insights about like what the people are saying, what's in objects in the video. Things like that. So pretty amazing stuff. So moving on, what can the content moderator do? So the content moderator is basically kind of a watchdog for like consider like I'm going to be showing off like this fake social media app, and so if people are uploading things, or maybe you have data coming, things like that, it will go through like text, images, and video, and it will flag things as it could flag things as things like it's maybe offensive, things that have like personal information, like you can check to see if you can go as far as like email addresses, like, oh, I don't want email addresses, phone numbers. It'll even check to see if there's like social security numbers. If anyone has kids on Roblox, this would be something like that. It's like, don't give out your address or phone number in the chat. Another part of the content moderator API is the review API. I won't be showing it here just because it's a little extensive for what I was doing, but a review API will kind of give you some infrastructure around like, okay, like I have an image, it found it to be possibly offensive. Well, nothing's perfect. I mean, if you ever posted something to Instagram and it's gotten banned or something, then it's not always offensive. So so there is a review API, and it's a whole infrastructure of like, okay, like I can have you could fire up Azure AD and assign maybe a group to review images, and it'll say, okay, I can submit this image to the review API. I can have people review it. They can okay it. They can assign, they can change something maybe, in the image metadata or something like that, or something like, okay, this is okay to view now. So yeah, it's kind of like it's a review infrastructure that you can just set up really easily. So I've talked about things being like adult or racy or things like that. That's very subjective. And so the content moderator API allows you to kind of create your own kind of lists and things like that. And then I went ahead and included that in my code because I didn't want to like swear a bunch like during my talk. So so I didn't want to swear a lot, so I made my own kind of what's called a terms list. and you can create it. You can just basically send up a list of words, or like maybe you have maybe you're McDonald's and you don't want people talking about Burger King on your chat app or something like that. So okay, so we'll move on here. We can go ahead and start the demo of the app. Just to go over the architecture of this app a little bit. It's not very extensive, but it's a Xamarin app. I'm going to be running it in iOS. It saves its images to Azure Blob Storage. And then I use Cosmos DB to save, the basically the cognitive service results and the image, and then I use that to kind of fuel my app. And so I'm going to move over to, this is my phone here. Just going to move over here real quick, make sure it's a little jumpy at times, but it's fine. Okay. I apologize about that. My 5400 baud modem is trying to keep up. Okay, so I've created the social media app. Okay. Okay, so this is a social media app, think like Instagram or something like that. You can post images and text and things like that. If you're running this, or if you're going to run this in the future, click the little ellipses, and the first sentence is actually a sentence that Azure Cognitive Services wrote. It kind of is a description that it thinks is in the image. The second part here, you see like the outdoor grass people. These are the objects that it sees in the image. So it sees that large group of people kind of in the middle. It sees the flowers and sees the clouds and the sky and everything, things like that. So really powerful stuff. We'll look at that here. If we go down here, same deal, a person holding an animal. Now, Joe Exotic, I guess, is not considered a celebrity yet, which, probably a good thing, but maybe not. So he's not considered a celebrity yet. So it's a person holding an animal. But yeah, things like that. First off, we'll talk about the content moderator API. Now, I wrote a terms list, so I didn't have to swear. So my term that I added to my terms list is fiddlesticks. Sorry if I'm offending anybody. We post this message. This message contains profane terms. It cannot be posted. Okay. All right. So we go over to Visual Studio here. For those following along at home, I have kind of this stuff separated. We have the moderator, we have vision, and then we have just that newsfeed app, or the newsfeed part of the app. If we go into the content moderator service, basically, and I mentioned before that this stuff is really simple to use. Basically, I'm using the Azure client library, and basically you create, with all this stuff, you create clients, and really it's just right here on this line. It's this text moderation screen text async method. So basically, I'm just sending up the text, and I pass it a term list ID. Now, the term list ID will go up here to create term list. I'll highlight this right here. Basically, you just create a term list object with the client, and basically it sends back like an ID, but you use that ID. You can name the term list and add as many terms as you want, and then you can use that. Here's a way to add, and the API is super simple to use. Basically, one method. The refresh index is basically just like, hey, blow away the index, and you have a new term list. And yeah, so that's how you can create your own term list, and using your the content moderator service is super simple with this method. So let's go back to the app. Let's actually add an image. let's add a landmark. Okay, so we're gonna add a landmark, and I'm gonna post a photo here. All photos, or we'll go to my demo folder, and we're doing a landmark. We'll do, how about the Opera House? Sounds good. It's uploading, doing its magic. Now, the way I have this app structured is it runs cognitive services on the device. And then, you know, if anything's going down, if something's wrong or anything, it won't upload it to blob storage. Another way you could use this stuff is you could upload an image to blob storage, and you could have some kind of like Azure function kick off, and then you could run these services like in a serverless function or something like that. And see how my landmark doesn't show up? It's magic. That's the magic of software and live demos. So, well, we'll blame test on that. But if you go down here and look at the ellipses, you see what Azure Cognitive Services wrote: a large body of water with Sydney Opera House in the background. So it knew that the Sydney Opera House was in the image. You see the objects that it detects in the image, and then the final column here, or the row, is the actual landmark we find. And so we can actually go over here to Azure Cosmos DB, their data Explorer, and we can refresh here. We can look at what we get back from cognitive service. So I've kind of flattened what the shape of the JSON that you get back from Azure Cognitive Services, is pretty deep. So I've kind of flattened it in this object. And so under image results, you have things like width and format and color and is it black and white and stuff like that. Now, if I had put up something maybe a little more racy, which I will not do, it might flag it as adult, and you have a confidence, you have a percentage out of 100%, I'm pretty confident that this picture is too adult. And so same with racy stuff. Now, this is what we saw before in the snippet. This description tags, these are the objects that it sees in the image. Things like dominant colors. Categories kind of goes deeper into like, okay, well, it thinks it's from the outdoors and things like that. No celebrities, but the landmarks, it sees the Sydney Opera House, and it's very confident. It's almost 100% confident that it's the Sydney Opera House. The caption is what I put: large body of water with the Sydney Opera House in it. And then tags are also the kind of the objects that it kind of sees, and the confidence. If we had moderator results in this, I did have a message, and it was just landmark. So it doesn't contain any personal information or profane terms or anything like that. So that's the output for that. So let's see here. Let's go here. Go back to the app, and let's try another photo. Maybe it'll show up. Maybe it won't. I'm not sure. Let's do a celebrity. Just a photo. Okay, this is Isla Fisher. She's an actress. She's great. If you've seen the latest Curb Your Enthusiasm season, she's the actress that they pay her to cry at things. So hilarious. So we're going to do this. Okay, Isla shows up. Yay! It's a miracle. Okay, so celebrity. So right off the bat, it's Isla Fisher taking a selfie. There's other objects. They're picking out things about her. And then the final row is is the celebrity who they think it is. So I don't know, if we went back here, I'm not going to go through this again too much, but if we go back here, we go down here, now we'll see like faces. There's it thinks it's female, which it's right. It always gives you a bounding box on things, so you can, I don't know if you've ever seen like those cool demos where they're like doing motion capture and things like that and detecting faces. You can put a bounding box over where the face is. It detects person. These are the objects, and then up here now in this one, the celebrities object is, it's an array because there might be multiple celebrities. So, but yeah, it has Isla Fisher in there, and it is very confident. So yeah, just going back over the code here for computer vision. Basically, so I'm running this as this stuff gets uploaded. I'm running this stuff. Same deal with the computer vision API. You create a client, and then this client has, this super simple method. It's like you send up the stream, the image stream, and then it gives you this magical results object. And this is all these on this all these methods are just basically, this is where I'm kind of validating and flattening the results back and creating my own result object to display in the app. But yeah, I mean, super simple. Basically, one line, and you send up, and you can get all sorts of insights on this on these images, and various things you could do with them. If you know what objects are in images, what maybe you can create profiles on like what people are using. Like maybe you ask people to take pictures of like how they use their product or something like that, and things like that. So it's pretty powerful stuff. Also, I wanted to show in my validation, when I validate, like, say, text, basically, I have things like, I wanted to talk about, like, with text, like the PII stuff. Yeah, like I said before, it'll pick out, like, social security numbers, even IP addresses, obviously bad terms for my list and things like that. But yeah, that all comes back in the content moderator API stuff. So pretty simple to use and pretty powerful, really. So let me just come on here and ask if there are any questions. I can come up with a question. Hey, Derek. I have a SQL Server database. Can I run Azure Cognitive Services on some of the data in my SQL Server database or my Cosmos DB? Sure, you can. You can actually create a kind of a search index, and you can create queries, and it will pick out certain data, and you can do all sorts of fun things. Like you can do like language analysis or the text analysis stuff if you put in images or things like that. So not just from kind of an app side, you can run this kind of stuff from a backend side too, in the data layer. About, oh, I got a question. Dan Bach, is there a free tier for Azure Cognitive Services? There is a free account for Azure, so I would probably hop on board with that. Just playing around with it, maybe a new email address. If you burn the free account, it's less than pennies to use, and I mean, I don't want to say like, I would say, it's not that big a deal to play around with, or you can just get a new Azure account. So. But it's definitely something that's super cool to play with. I've run stuff from a Raspberry Pi. There's all sorts of calculators and things like that. There is a free, so like with my app, there is a free tier of Cosmos DB. Azure Cognitive Services is not very expensive. I mean, less than a penny per call. So I don't know. Yeah, I mean, if you're going to do some kind of crazy workload or something like that to test out, but yeah, but or just get a new email address, you know. Yeah, I think. Thanks, Drew. Yeah, $1 per 1,000 transactions. You know. Yeah, everything's free things is also nice. Yeah, thanks, Dallas. Yeah, I mean, you can. I mean, you can go in and you know, you can get kind of an analysis of like how much it can cost. But if you're just playing around with it, if you're just sending up images like I'm doing or something like that, it's I think my bill last month, you know, and I was like really hitting the app pretty hard. I think my bill last month was like $3. So I mean, I was hitting it a lot. So. And that was for storage and Cosmos DB and all this stuff. So. Oh, yeah. Like I think, I mean, if you prop up some kind of like VM or something like that, like if you prop up, you know, I don't know, if you leave like Azure Kubernetes service up or something, you know, that, you could definitely get burned. I mean, yeah. I mean, we have clients that do that. So yeah. This is as pay as you go stuff. So maybe a little safer. So yeah. So, all right. That's right. Yeah. So you can just cut it off. You can say my budget is, I spent about $3, maybe go $4. So yeah. Okay. Zach the Animal Gardener. Give us the magic, man.
Zach the Animal. That's a new one. I've never heard that one before. Normally it's Zach the Snack. So first things first. Thank you all very much for participating in this somewhat of an unusual setting. I admit I've never done a virtual presentation like this, so it'll be fun. Before we get started, you know, this is definitely a marathon, not a sprint. Some of us have probably been sitting for an hour or two, you know, kind of get a little stretch, get a little bit of the blood flowing, you know, a sound mind and a sound body, as the Romans used to say. So, heard a lot of really good information, and it's actually great that I'm the anchor because a lot of what you've heard kind of leading up to this point will hopefully be a little more solidified. You'll be able to see how exactly these things can apply to some of the applications that you build. The presentation that I'm going to go through today is specifically app services. Now, we could probably spend like this whole session just on all of Azure's app service offerings. But the spin that I want to give it is specifically for those of us that are in the enterprise. I'm currently, my primary client is based on the East Coast. It's a large healthcare system in New York City. And as you can imagine, things there have been relatively interesting over the past, you know, weeks and months. So very, very large organization, 60,000 employees, huge IT staff. So we have a lot of different, you know, tiers of enterprise architecture that we have to, you know, make sure get approval for our applications. And app services has actually been a way that we've been able to position ourselves within the existing confines of, you know, what people understand for on-prem, and show them how we can move to the cloud by minimizing risk, but also maximizing our ability to return on the applications that we need to move into production. So, as I said, my name is Zach Gardner. I'm a senior consultant here at Keyhole Software. I have trimmed my beard since that picture. Don't worry, I'm not an evil imposter. So, the best way to understand how app services will be able to work for you is kind of start from the outside going in. So first, we're going to talk about the context in which you're going to be deploying your application. The type of application that I'm targeting in this presentation, it's not your set up a function or two, set up a logic app, and then magically make millions of dollars. It's the type of application that really is the heart and soul of a business. We have a application that's going to production in Azure, hopefully by the end of this quarter. And we have another one that we just started development on, and it's going to be going live in Labor Day. So these two applications are going to be used by 20, 30, 40 people. Some of them sit at on client sites. Some of them are ambulatory facilities. They have a lot of different use cases. They have a lot of different concerns. So how exactly we structure our app, we have to understand kind of from the outside looking in. Next, we'll talk about the shell, so to speak, of how these apps actually are running. And then we're going to talk about some fun stuff like the edge, things like a web application firewall, because you're going to have this thing out running in a public cloud. How do you make sure that you're not exposing yourself to SQL injection or any of the OWASP top 10 vulnerabilities? And then after we talk about the edge, we'll go into the actual application itself. How do you get your code from your developer's machine up to Azure? What is it that the thing that you're actually deploying to? And what are your different options there? You could go AKS if you want to do Kubernetes. You could do Azure Container Images. If you don't want Kubernetes, but you still want to use containers, you could do a VM. I wouldn't recommend it. I like being able to go to sleep at night and not having to worry about my phone ringing at 2 a.m. or some patching schedule coming out. I would rather pay Microsoft to worry about those kinds of things so I can worry about my particular business domain. Or you could go the web app route, which is kind of a nice balance between IaaS and functions as a service. And then finally, can't forget it, operations. Once we have this code there, once we've solved world hunger and made it slice bread, how are we going to make sure that this thing is actually running? How am I going to get alerted when my application takes longer than 2 seconds to respond to API requests over a 5-minute interval? Those are the types of things that you really need to think about before you even dive into this. So we'll talk about the context in which your applications get deployed. There's not a lot of presentations that I've seen that have been done specifically on this topic, but as we've developed and are going to get deployed our first application to Azure, this has actually been one of the most contentious things about moving an application into production that we found, sort of just kind of by surprise. So talk about how we actually get into the cloud. Of course, we have Microsoft, sort of overseeing this whole thing. And when a company wants to use Azure, the way that my client has it set up is everything is under a single enrollment. You can think of that as like the American Express Black Card, the thing that has like no limit, like this is like the single credit card that we're going to put all of our charges against. And that is sort of the place where the contract begins between Microsoft and your company. And everything that gets deployed lives under that umbrella. Now, if your company has a sub-company that they 100% own, theoretically, you can also use that enrollment. But if they are, if they have a minority stake in it, but maybe they're a service provider, then you might want to get different enrollment, because that's really going to be sort of a different billing structure as well as a different auditing structure. If you have things to worry about like HIPAA compliance, PCI, if you do credit cards, if you're having an application that is going to be a multi-tenant application, you really need to talk through with the people that are actually going to be sort of overseeing and have entered into that contractual agreement with Microsoft, with how exactly they structured that arrangement. Because you as an application developer or an application architect might say, all right, multi-tenant, like, why wouldn't I want to go that route? Well, if you go down that path and you haven't sort of checked all the boxes beforehand, you might be developing something that maybe the contract itself doesn't support. So that's sort of the enrollment spheres, who's going to get the check? Like, which accounting department is going to get the check? Well, it's the bill at the end of every quarter. Now, within an enrollment, there's sort of two high-level concepts that I want to make sure everyone understands. There's a subscription, and then there's a tenant. The tenant you can think of as kind of the Office 365 piece of it. That's where you can define things like role-based access. It's where your authentication and authorization really takes place with respect to. And every subscription is not necessarily created within a tenant, but it's created with respect to a tenant. So if you have requirements in your application that all audit logs for this application need to be separated completely from the rest of the enterprise, then your application would actually need its own tenant. But if you have a large IT staff and they're the ones responsible for supporting some of the underlying infrastructure, whereas your team is responsible for operating on the actual application itself, they need to be made aware of the fact that there's going to be potentially different tenants for this application. And when they need to set up the role-based access, it would be specifically in that tenant. So fun little gotcha that I've been working on in the past 2 or 3 weeks. The subscription is kind of like the top level shell that most people are probably familiar with when you actually go to get ready to deploy resources into Azure. MSDN accounts, at least our client, every developer gets sort of $150 a month against a subscription specifically for them that they can play around with, that they can do what they want with. And as soon as it goes over $150, the cord gets pulled, can't charge anymore. The discussion that we had at the tail end of Derek's, one of the interesting things that you can do with subscriptions is you can set up sandbox subscriptions that allow multiple developers to play around outside of their $150 a month, and that allow them to provision resources separate from your bona fide subscription. You'll probably want to have subscriptions that are specifically set up for, production environments. You might have a dev and QA subscription, but that really don't allow developers to provision resources, because you're going to want to make sure that your resources are secured. You're going to want to make sure that traffic that gets in is really monitored, and that traffic can't leak data back out. And the types of resources that get set up, those should really be done sort of by experts and subject matter experts in the field of setting up those resources. We as application developers, we know our domain really well. We know our users really well. We know their needs really well. I don't know Azure virtualness as much as I know how to structure an EMR. I don't. I'm not an expert in it. So sandboxes allow you to set up subscriptions, allow you to set up places where developers can deploy things as separate from environments that have sort of bona fide data in them. So subscriptions can kind of live alongside each other. You can structure them so that they have different budgeting requirements, and then a resource group lives within a subscription. The best way to think about a resource group is all of the resources that make up your application, your database, your web app, your function app. Those are sort of, they're homogeneous. They move as a unit, and they are not necessarily codependent, but they sort of live together. They have like a common law of marriage, so to speak. That is really what we would consider in an application dev a environment. So we would probably have one resource group for dev, one resource group for QA, another one for staging or pre-prod, and then another one for production. The resource group is probably the best place actually that you can see where the billing takes place, because the resources are the things that create the cost, and all resources live within a resource group. So if you see that you have a resource group that's spending, like a dev resource group, that's spending $60,000 a day on like a 12 cluster Cosmos DB instance, which has happened, you're able to pinpoint that a lot more carefully and a lot more quickly than if you just had sort of a mishmash of things going on. So definitely think about sandboxes, definitely think about different subscriptions for your devs, your QAs, as separate from environments that have PHI or PII. And then tenants, make sure that you really understand the auditing requirements for your application. And enrollments, make sure that you really talk through contractually what it is that you as an application architect or developer are trying to build, and make sure that it's in compliance with whatever Enterprise Enrollment has been agreed to. Next up, we'll talk about the shell. So, picture it, we're in a subscription, let's call it dev, why not? We're in a resource group, let's call it dev, because let's be consistent. Now we're getting ready to actually deploy our code somewhere. We'll have to live within something, and that's where the app service plan starts. With an app service plan, you can define what type of OS you want the underlying VMs to be. Now, all of this is really geared towards platform as a service. Infrastructure as a service is really good if you have some very specific needs. Functions as a service are really good if you listen to Radiohead, you like dark coffee. It's not for me. I like lightly roasted coffee from either Central America or Africa. And I don't want to have to worry about, spinning up VMs. I also want to have a little more control over how my functions work, how my applications work than functions gives me. So platform as a service, it's the nice go-between. But platform as a service really just means that Microsoft is the one that has to worry about provisioning these VMs on your behalf, and you don't have to worry about it so much. The app service plan level is where you get to pick, what OS the underlying VMs are going to be, which region, or if you have DR requirements for a particular environment, what region you want these things to live in. And you also get to pick things like the size as well as the SKUs. So just to put that in perspective, when you create the app service plan, you'll be selecting the subscription, the resource group, kind of going back to the two previous slides. You get to name it My App Service Plan. You get to pick the types of VMs, and you get to pick the region. And then when it comes to the pricing, they have a ton of different options. For dev and test, that's more than likely what you're going to select for a development or a QA environment. For a pre-production or a production-like environment, you're going to want to go with the production tier. Even though it does cost a little bit more, and if you want to see how much it's potentially going to cost you, the Azure resource calculator is a great way to figure that out ahead of time. You want to have parity with as much as you can between production and pre-production. So production doesn't want to be the first environment where you're testing these things. You want to have an environment that's very, very close to it, if not equivalent. So you'll be paying a little bit more, but you at least get to see sort of the more traditional, the most common options here. Now they do have additional options. If you click on the additional options here, those are less used, and I would probably steer away from that. They have shown these options set up because more than likely these are going to be the things that you're going to be using more often than not. Isolated is if you have a very, very specific use case. For the most part, for most of the companies that we consult with at Keyhole Software, production is probably going to be sufficient. But definitely talk to the subject matter experts and make sure that what you're provisioning actually meets their expectations too for, ITsec, InfoSec, as well as corporate compliance. So now we're almost there. I promise we're almost there. We're to the point now, we have something where we're going to be executing our application within. Now we need to protect it. And that's where the application gateway with the web application firewall comes in. This sits at the edge between the abyss of the internet and the purity of your application. It's great if you're going to be doing microservices, because when a request reaches your web application gateway, it can say, oh, if it's /API/patient, route that to the patient's microservice. If it's /patient/task, it can route that to your task service. So without the underlying service actually knowing like how it is hosted, your application gateway allows you to do that sort of partitioning. Azure has a couple different options that you can use as an edge. Azure Front Door is another common one that I've seen. There's also Azure API Management. If you have more of a service mesh, if you have a lot of different microservices that are sort of moving in and out of production at will, for our applications that we develop, they're typically, some of them are microservice based, but it's, we start these microservices up, we put them up there, and then we move on developing our next feature. And the only time we ever really touch them is for bug fixes or hot fixes or the occasional feature enhancements. And they are isolated from the rest of our application, and the cognitive load that we have to go through when we develop new features is much less, because these things are there. When we go to production, we could probably do a spot check on them, but we're never touching them. So we have, a couple of them out there, and the application gateway is sort of the way that traffic gets through it. Going to the next slide. This is what the application gateway setup page looks like. So you pick your region, you pick the tier. There are versions of the application gateway that don't include a web application firewall. If you have and this is why it's also important to talk to your infrastructure people, if they already have something like a Palo Alto or a Imperva web application firewall that's filtering all the traffic for you, there's really not a lot of benefit that you're getting to adding an additional web application firewall in your application gateway. IT security folks will never get in trouble for recommending that more security be added on something. But if you're paying for it and you're not getting any benefit because that traffic's already been filtered out for you, why do it? So talk to them, make sure they understand what you're doing, make sure you understand what they're doing, and that'll help guide you on some of these choices as you're setting up your app services. It takes care of auto scaling, and you can add in firewalls, you can do availability zones, HTTP 2. Again, if you like Radiohead or Semi Impala, if that's sort of your thing, you can set those up. But most importantly, we talk about routing. So application gateways have a concept of a backend pool. That is the thing that's actually receiving the forwarded traffic. So in my example, I'm targeting an app service, and the actual app service itself is a function app that I set up. You could have it target a VM if you wanted to, though most of our use cases for our applications, we're staying away from VMs. Some other applications in our enterprise don't, and they have very valid reasons for doing so. But the backend pool represents what's going to receive this forwarded traffic, and then the HTTP path, that's actually how you say, when something comes in and it comes on an /API/, I want to redirect, or I want to just forward the traffic on to my particular backend target. So now's the fun part. Now we actually get to talk about what it is that we're going to be deploying. I have been deploying applications to VMs on-prem that have either in the past life a PHP server set up, or a Tomcat server set up, or an IIS server set up. I know how to do those things in my sleep. And one of the things that I really like about Azure is that it takes care of a lot of that stuff for me that I used to have to worry about. The web app, think of it like a managed instance for the .NET folks. Think of it like a managed instance of IIS. It starts Windows, it starts IIS, and it gives you a place where all you need to do is package up your code using, MS Build or the Azure SDK and give it to it. You don't have to worry about, well, you could also add SSL certs onto it. You could have the HTTPS termination at the application gateway if you want, but you don't have to worry about a lot of the stuff that we normally do. If you want to scale this thing up, all you do is click, 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 scale a few buttons, new VMs are provisioned, your application code automatically gets deployed to those servers, and you're done. And what that leaves you time for is spending more time with your application users, spending more time thinking about your requirements for your application, and less time having to worry about what it is that's actually running and patching schedules and all that stuff. So the best analogy is definitely sort of a managed version of IIS that you just throw code at it and it hosts it. Now, for my Java friends in the room, think about it like a managed version of Tomcat. You give it a jar file, or you can give it a WAR file if you want to. It is 2020. The world has sort of moved beyond WAR files, but if you're not on Spring Boot, totally fine. This also handles legacy applications as well. If you're on PHP, you've made some interesting life choices getting here. I was in PHP for about 5 years of my life, so no judging. Microsoft has definitely moved beyond what it was, 10, 15 years ago, where it was very Microsoft. With web apps, they support other languages, other tools as sort of first-class citizens. Or if you want to, you can even bring your own container with this. So where this kind of sits, web apps specifically in the spectrum of where you can deploy your code, if you're going with more the Kubernetes route, if you have a service mesh of, maybe you have like a Java service, but some things are written in Python, maybe some things are written in Node.js, and there's a bunch of different teams all moving things in and out, and services are sort of communicating between each other, which we don't recommend too much in microservices if you can avoid it. But if it does, then you have lots of IPs to worry about. You have a lot of routing tables to worry about. Azure Kubernetes service is a great place to put that stuff, and you have a ton of different things that are moving in and out at will. A step down, or maybe a step to the side from that, would be Azure Container Instances. You have something that can be represented in a Docker file. There's not a lot of crazy configuration that you need under the covers. It's pretty straightforward. You might have some scaling requirements. You might have to worry about if your tax software, typically Q1, maybe a little bit of Q2 is your heavy time, and then you want to kind of scale it down throughout the rest of the year, and you don't want to have to worry about VMs. Azure Container Instances are a really good place for you to put that. Web apps kind of sit to the other side of that, and I have some legacy .NET Framework code. I have some new .NET Core code. I know how to package these things. I don't really need containers. I don't have anything that I need to install on my Docker container if I did get one. All I need is just some instance of IIS that auto scales in the cloud, and I give it to it, and I don't have to worry about it. That's sort of where web apps sit. On the other side of, I think it's the world icon, if I remember right, are web jobs. Some of the things that, I would say probably 90% of our code that we write is, very transactional. Like an HTTP request comes in, we have a connection to a database that's pooled up, we go fetch some data, or we update some data, or we insert some data, and then return to the user. About 10% of it is background jobs, things that need to wake up periodically, maybe send HL7 messages, depending upon what's happened in the system, or send some fire messages on a queue. And those, the equivalent to that, to Hangfire, would be a web job. There are things like background tasks and asynchronous processing. Web jobs are actually a subset of web apps, and getting those started up is like so simple. I was able to even figure it out. So you have your transactional processors and web apps, you have your background processors and web jobs, but how do you actually know that your application is working? How do you know that, how can you get to your logs when something happens and you get a trouble ticket in? You want to figure out what exactly was going on with that user. That's where App Insights down at the bottom. So it's it's nearly plug and play for being able to ship off those kind of logs to a centralized location. Because you're going to have, a bunch of different underlying VMs producing logs. You're going to have a lot of applications that are producing logs. How do you put them all in one place that you can search for things, that you can trends over time, and that you can get alerts if things are suspicious, if availability is down or performance takes a hit? That's where application insights sits. You give it you install a NuGet package, you give it a key and an app config file, and you're done. It listens for top level exceptions. It allows you to use the dependency injector to bring in an instance of a logger, and you write your logs, and sort of magically they appear for you in application insights. There are a couple on-prem solutions that it is kind of similar to. If you're familiar with the ELK stack, which is Elasticsearch, Lucene, and Kibana, which actually I think they changed it to the Elastic stack, which is more Windows service file beat, shipping stuff to Elasticsearch. It's sort of the spiritual successor for that. And I, as a person who had to set up our application performance monitoring stack, which we're using ELK for it, it's very nice not to have to worry about when a Windows service goes down. We stop picking up logs on a particular microservice, having to remote into a VM and restart a Windows service. All of that is taken care of for me by application insights. So if anyone knows anyone that works on that team, give them my thanks. So in this screenshot, we're going to just create a very simple web app. We're calling it My Awesome Web App 1, 2, 3, 4, 5. Because why not? I'm going to use code to be able to, that's the type of provisioning that I want for this, because I'm going to give it through Azure DevOps an instance of a .NET Core 3.0 app. From my list, I have, the LTSs, I have 3.0 here, but if I want, I could do Java SE, I could do Tomcat, I could even do Java 8, if I'm feeling particularly old, and fun, old people have fun too. And that's it. It provisions something, it creates the virtual instances, and then I can go to Azure DevOps and say, all right, I want to build this thing, and when I want to release it, here's the app service I want to deploy it to, and it just goes. It's actually kind of crazy. I got one set up yesterday, all the way through the entire pipeline, building out all the resources using the Azure Resource Manager. I think it took me maybe 2 hours with constant interruptions on Slack too. So it's incredible how easily I was able to get this thing up and running in a very, very complicated setup that if I were to try to submit service tickets or getting someone else to provision it on-prem, it would have taken me 7, 8, 9, 10 times as long. And it probably wouldn't have been right either, and I would have had to go in and fix it anyway. So the other option, other than code, is a Docker container. It supports both Linux as well as Windows as the underlying OS, and then you get to pick the region that you're in. So that's really the web app is the heart and soul of probably what most of us are going to be working on. It's the thing that's really going to make us money, but it's also going to, more importantly, satisfy our end users. It's the thing that actually receives the request, that does the work, and to our users really represents what our application is. But if we're going to be a fiduciary on behalf of our users, we want to make sure that our application is actually performing correctly. So one of the other things that I was able to do in those 2 hours with constant Slack interruptions is set up an application in App Insights, a performance monitor. So I can see at a glance what the different performances are like of all the different APIs that are called. And I can even look at things in 50th percentile, 95th, 99th. Like, I've tried to get this set up on the ELK stack before, and it was not this simple. I will say that, and it did not work this well. And I get this out of the box by using app services. If I want to do the equivalent of tailing my logs, this is what App Insights offers. You can see requests as they're coming in. And I've used this, I'll say personally, at least 10 times to triage issues with my QA team. Like I'll have my QA team, after they report a bug, I'll have them sit there, recreate the bug, and I'll be looking at the logs as they come in. And it has reduced the turnaround time greatly for how long it used to take for us to, wait for the logs to come in, try to analyze them, try to find them, filtered out all the traffic. So don't got to do that anymore. It's all right here. And I can very clearly see when exceptions happen. I can click on any one of these, and I can get a list of all of the logs that came in before it or after it. It has made the process of turning tickets around a lot quicker than what it used to be. And then availability. If I want to search for logs, if I want to look at exceptions that happen in my application, it allows me to do a free text search, very similar to like a Lucene search. And the logs that come in, I can click on them, I can see what happened. It makes it a lot easier if you have, a specific user that you're looking for events for, as long as those are a username is included in your log. Bada bing, bada boom. You search for them, you see the logs here. You can pick the time that you're interested in. It greatly helps the ability to actually see inside of your application and see what's going on, and very minimal setup on behalf of you as an architect or developer to get this thing working, because you honestly have more business critical things to do with your time than manage and groom stuff like this. If there's just something you can put in there and it gives you all of these benefits with none of the cost, yeah, why not do it? So now we get to operations, one of the parts that we as fiduciaries cannot forget about. There are so many different things that I was trying to figure out how to tell you all about for what app services offer, but I narrowed it down to just this three. I get, and I'm not kidding, yesterday, I got a budget alert from one of my resource groups that was spending like 40% more at this time of the month than I thought it should have been, which is very important to know, because now that we're in the cloud, the pricing model and the accounting model is completely different than it used to be. We used to have to spend, $4,000, $5,000, $6,000 waiting, maybe 1 or 2 months just to get a new production grade VM. Now that we're on Azure, that's sort of switched from CapEx to OpEx. And I have the availability to provision these things that have been provisioned for me sort of under the covers. But if I'm going to do that, I need to know how much it's going to cost. I need to know when I'm meeting my certain budget levels. If you only have a budget alert that lets you know when you've met your quota, that's not going to do you a lot of good if you meet your quota 15 days into the month, because then you've already have another 15 days left in the month, and you're like, uh-oh, like, what did we get wrong? So budget alert, I have set at a subscription level, and I'm able to get a text and an email when we hit the 50, 75, and 100% marker. And it's with that the VPs and the directors that we ultimately report into have gotten sort of comfortable with this difference in accounting model that we're introducing with going to the cloud and going to app services, because it's not a fixed price anymore. It's variable depending upon how much you use versus how much it's sort of sitting around and waiting for requests to come in. SLAs are also very important to understand for all of the different app services that you use. Most Azure resources that you use, it's probably a good rule of thumb to have at least 5 nines on their SLA. And it doesn't mean that the availability is going to cut out all at once to get you to that level. It could be, that maybe there's a second on, January 4th this year where things were kind of wonky, but then everything came back. So as you're developing your application, it is different than how it used to be for on-prem. On-prem, I could trust that my Active Directory server was always going to be online. Well, I could trust that the people that ran the Active Directory server would always tell me that my Active Directory server would be online. They didn't always work out, but I never had to worry about things like, request retries or displaying something to the user, letting them retry it if it's failed after so many times. There are a lot of different moving pieces that you're going to be getting into here when you go to Azure. And it's important to really test this stuff thoroughly, because your whole thinking has to completely change. Like, what Dallas was talking about, what Michael was talking about. It's a different mentality when you go to the cloud. You have things that you could rely on before, and it's a mind shift to be able to get to the cloud. So make sure you understand the SLAs, and you might have to use, higher tiers of some of these services to meet your SLAs. Storage accounts, I will say, probably the highest SLA I've ever seen. I think they had 16 nines, which I didn't even know that was like an option. So some of them very, very good. You don't have to worry about it all. Some of them, if they have like 5 nines or 6 nines, just make sure you understand the implications of that as you're writing your application and sort of build accordingly. And then application SLA alerts, I already mentioned, I get an email and a text. So it's very fun to see some of that stuff. So some of these alerts are actually already set up for you by using Azure App Services. It is able to do some sort of machine learning to be able to say, the number of failures is sort of abnormal during this period. So when this happens, I get a text and my director gets an email as well as I get an email. And you can go in, you can see a trouble report, and you can see sort of the logs around that time. It lets you get insight into what your application is doing in a way that when we were on-prem, we didn't really have a way of seeing these things. Availability of your application too is very important. I have 2 tests that I'm running constantly on my application. I want to make sure that my API is up as well as my UI is up. If there are users that are in specific parts of the country that are having issues accessing my application, I can even set up different availability tests in different zones of the United States to see, just a very simple ping test. How long does it take, and what availability percent am I at? And if I dip under a certain amount, guess what? My phone gets texted again. It is awesome. I've never been so happy to get so many texts in my life. And then when it comes to budgeting, you set a amount that you want to use. You can say the period in which the reset occurs. You can choose an end date, and then you can say, when this percent of the budget, which equates to this much, what do I want you to do? Again, my director gets emailed, starts asking questions, and then I get a text too. So all of these things you can get set up in under the span of 2 hours. It is amazing, actually, how much of this is sort of managed for you. I've found that I personally have spent probably more time trying to explain to people how these things are set up than it actually took me to get set up. And that's one of the hardest parts, honestly, of moving to Azure. You all as sort of forward thinkers looking and being on presentations like this are going to be the ones that are really driving the innovation at your company. And there will be some resistance, but all you have to hear about are the case stories that have come out of Microsoft, especially during COVID-19. The amount that the companies, the clients that I'm at, that they've been able to innovate and be able to deliver results back to the patients that they serve, especially in the New York area, by being able to leverage things like function apps, logic apps, and app services. It's truly amazing how quickly the adoption of some of these things have come. And they've come because they work and because they're able to get things into production quickly, and they're able to focus more on what it is that they're trying to accomplish than having to worry about, disk striping or any of those fun things, which you can go with if you really want to. But for me, I enjoy, simple things in life. I enjoy a good cup of coffee, and I enjoy developing functionality to use it. So with that, any questions or anything, any thoughts, any things that you want me to talk more about. If you do want to talk more, privately, contact Brian, contact anyone at Keyhole, pick your favorite Keyhole person. And just as a shout out, I do like lightly roasted coffee. So if that sways you at all. All right, I will turn it back to you, Ryan.
Perfect. Well, we appreciate it, Zach. And that's all the presentations that we had scheduled for today. Make sure to visit our presentation guide, slide decks, additional resources, along with more information about us at Keyhole Software. Please feel free to reach out with any other questions you may have or anything we may be able to assist with.